Hello everyone, this is Sean's video. In English, you can call me Sean, but actually my Chinese name is Shao. But it's okay, you can call me Sean or Shao. If you are my students, I have made the introduction in class, and this is my YouTube channel, and it is also my first video put on YouTube. The reason I do this series of video is that when I do a TA, I find a lot of students, they are either not interested in chemistry or just very busy about some other things. So I just want to make this series of video to say something that I have no time to say in class. And also it's a record of my spare time, so I feel very comfortable and relaxed when I do this video. I don't have pressure. It's not like in class I have time to prepare and I should organize everything well and watch everyone's safety. But here it's at my home, so I feel free and relaxed. So the material covered in the PowerPoint will not be scientific or it's just like introduction, or just you can just look at it. You can just watch it as a video for fun. That's it. You don't have so much pressure here. So yeah, and my plan is to make a series from Chem 1A to Chem 1C. Hopefully I can finish this task. It's pretty tough, I think, but I will try to complete this series. So if you have some comments or recommendations or questions, you can come to me in person or comment below. Okay. Yeah, let's start. So today's video won't be very long. I want to talk about the direct and indirect measurement. The reason why we measure is that we want to describe the external world objectively instead of subjectively. For example, if I reach my hand into water, I will say it's hot or cold, but it's not science. We want to know, if we want to know the temperature, the relationship between temperature and other stuff, we cannot use hot or cold. We have to get a number. So another motivation we do measuring is we want to review the intrinsic relationship between different things. As you can see, it's not very scientific. It's very casual. Yeah, actually it's a casual video. And there are two methods we do measurements. First is direct measurement, and another one is indirect measurement. So what are they? For the direct measurements, it means we're measuring exactly the thing that you're looking to. The most popular example is the length. As you can see, we measure the length of each object in centimeter. For example, in this picture, maybe this ruler is measuring it's measuring an eraser. He finds the length of this eraser is 5 centimeters. Actually, it's not. It's 5.0. This kind of mistake is often made by other people. They are not in science field, so they are not very careful about giving the result. You can say 5 centimeters in daily life, but actually in science you should use 5.0. The difference between 5.0 centimeter and 5 centimeter is very, very big. It's called a significant figure, and it will be stressed by me over and over again because it's really important for science. So let's just forget about this mistake. I just want to show that measuring the length is a kind of direct measurement. Okay, but in most cases, the measurements are made indirectly. So let's say, what is indirect measurement? Actually, in world, most measurements are indirect measurements. They're using one variable to represent another variable based on physical relationship or other relationship, but most of them are physical relationship. And also it needs to be calibrated. You can see the ruler, we don't have to calibrate the ruler, but for others, for example, the ammeter or the thermometer, we have to calibrate it. I don't have to dig very deep about what is calibration. You will have the feeling over time, hopefully. So here, for example, some people may say, yeah, I know direct measurements means I just get the result, just get the reading directly. Actually, it's not. Direct measurements means I don't have to do any physical calculation, or there is no physical relationship involved. The things I want to do here is to show you that for the graduate cylinder, you can say, for example, 30, when the water level reaches 30, you can say, wow, it's 30.0 milliliter. I read directly, right? So it's a direct measurement, but actually it's not. Let's say the indirect measurement means we represent we use one variable to represent another variable based on physical relationship. Here, from 0 from the bottom to 30, actually it's a length, right? It's a length or height. It's not the volume, right? Volume is not something like this. So actually you are using height to represent the volume, you see? But the requirements is the area of the bottom. So if you know the area of bottom, you get the relationship between volume and height. Okay, so that's a very classic example of indirect measurements. But for the thermometer, here is also very classic. You cannot just see the temperature, right? It's not like a height or width. You can see it, but for temperature, you cannot see it. You can have to feel it. But some guys come up with this idea. When the temperature goes high, the volume of a liquid will become bigger or will increase. When the temperature gets colder, the volume getting smaller. So we can describe this kind of relationship in this formula. The V is a linear relationship with T. So if we get the volume of the liquid from one point and another point, then we can get the temperature relationship between them. You see? So that's the reason we need to calibrate, because the A and B here is undetermined. So yeah, we have to do several plots to plot this diagram to see what's exactly the relationship between V and T. But you can just forget about it. It's work done by the technician. All the thing you should do is you should understand from here to here is not the temperature. If the water level rises from here to here, you are measuring the length. You are not measuring the temperature. The reason you can get the temperature is that there is a relationship between temperature and the volume or height, because they are interchangeable, right? Okay, and one last example is the ammeter. So actually the principle of ammeter is a little bit complex, so I don't want to dig so deep to give you the relationship involved in this apparatus. It's called magnetic effect of current. Generally speaking, is that when a current go through this stuff, let's say, and it will create a magnetic effect. There's another magnetic particle inside, so it will produce a kind of force between them, and then it will lead to the move of this needle. So it will move. The more current you go through, the force become, let's say, stronger. So the needle will go higher. So actually here you are not measuring the current, you are measuring the force. This is like an indicator, indicate the force inside, and then the force has somehow connected to the current. So we can use this kind of stuff to represent the current here. It makes sense? We are not measuring the current using this guy. Actually, this guy are measuring the force between inside this stuff. And somehow this stuff has a kind of relationship the force here is rely on the current go through the wire. So yeah, that's the it's very short, right? So we talk about the direct measurement and indirect measurement. And in the first topic of our lab, we want to measure the density. Actually, it's also an indirect measurement, because you cannot just see the density from outside. You have to measure. You have to measure the mass. You have to measure the volume, and then use the rho or density equals m/v to calculate the density. So that's called indirect measurement. Actually, measurement you can come across if you're a science major, for example, physics, chemistry, or biology, or for example, electrical engineering. You're dealing with temperature, you're dealing with the measurement all the time. But keep in mind what you are measuring for. What you are measuring. What exactly you are measuring. Okay, thanks for watching. That's my first video. I feel happy now because I finished one goal I have made before. Okay, thanks for watching. If you have any comments or questions, you can comment below. Thank you so much.